All right, here's task number 2. You might want to have your unit circle available. Calculator if you need it. But we are going to use what we know about radian measures to go ahead and find the cosine and sine values. And remember that the cosine and sine values were the same as the x and y values that go around your unit circle. So I'm giving you a hint there that you could do that. Now, granted, if you were in class and we had to test on this, I wouldn't let you use a unit circle. So you should know how to do it without it as well. So if you don't remember what degree pi over 4 equals or where it's located on the unit circle, because it's all new, so very reasonable, you could convert this 2 degrees. So we multiply pi over 4 by 180 over pi because we want it in degrees. And 180 divided by 4 equals 45 degrees. So we know that this is pi over 4. And it's a 45-degree angle, which is what special kind of right triangle? It's a 45, 45, 90 triangle. And what we saw in the unit circle before is that when I have a hypotenuse of 1, that my x value here is root 2 over 2, or this side is root 2 over 2, and so is this side. And so my values here at the unit circle ended up being positive root 2 over 2 and positive root 2 over 2 because in the first quadrant, both of my values are positive. So you could either write your answer as an xy coordinate like that, or you could say cosine of pi over 4 equals root 2 over 2. Notice you can check this. You can switch your calculator to radian mode and you can actually calculate it, but it would give you the decimal anyway. But you could check your work. And sine of pi over 4 is root 2 over 2. Right? So when you guys get done, you can pause it. Make sure you get your notes down from this. We're going to look at one that maybe is a little more challenging than pi over 4. So we're going to look at 7 pi over 6. Where in the heck on the unit circle, if I'm not looking at it, where is 7 pi over 6? So honestly, like, until you use the unit circle a long time, it's best to just convert it 2 degrees. So we get 7 times 180 all over 6. I'm going to grab my calculator because I have been known, especially in these videos, to make lots of math errors, so I'm not going to try to guess it. But it equals 210 degrees. All right, so 210 degrees, if this is 180, 210 degrees is 30 degrees past it. So we're out here, and this angle here is 7 pi over 6. This is where we want to talk reference angles. So the first example we did like this was easy. My angle was 45 degrees. That was also your reference angle. My angle here is 210, but my reference angle is this little angle here. This is my reference angle that is between the nearest x-axis and my terminal side. And I want to draw my triangle because I'm going to use my knowledge of special right triangles to fill this in. So we know if this is 180, then 210 is 30 degrees past. So you can say your reference angle here is 30 degrees. So guess what? We have a 30, 60, 90 triangle. And we know that the short side of the 30, 60, 90 triangle with a hypotenuse of 1 is 1/2. And the long side here is root 3 over 2. And now we just need to decide what are the actual signs on that. Well, I'm over here in quadrant 3, and my x values are negative, and so are my y values. So I can say that cosine of 7 pi over 6 is my x value, is a negative root 3 over 2, and sine of 7 pi over 6 is a negative 1/2. Right. Go ahead, if you need to, pause and get your notes down for that. I'm going to give you some time to try these, and then we'll go over them together. So pause the video. You could grab your unit circle to do this, but I challenge you to try at least one, like how we showed on the previous 2 slides. All right, so hopefully you know that pi over 6 is 30 degrees. So here we got pi over 6 here. And we know that it's a 30, 60, 90 triangle. So my long side is root 3 over 2, and my short side is 1/2. So cosine is root 3 over 2, and sine is 1/2. All right, negative 3 pi over 2. Hopefully you guys figured out that was negative 270 degrees, but you could also count it. Here's negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2. So I'm up here. This is the point I'm talking about. It's not a special right triangle, but I know that point because my x value here is 0, but my y value is 1. And so my cosine is 0 and my sine is 1. All right. 5 pi over 4. Hopefully you guys figured that out. That was over here. It was at 225 degrees. So this is 5 pi over 4. It makes a 45, 90 triangle. And we know the sides on that are always root 2 over 2, root 2 over 2. But we know in the third quadrant that both of those values are negative. So we have cosine is a negative root 2 over 2. And we have sine is also a negative root 2 over 2. Right. Again, remember I am available for office hours really any day. I just have them specifically Tuesday and Thursday at 1. You can email me questions on this. You know, this is where trigonometry starts getting a little more difficult, and it's probably harder in this remote learning. All right, here's something you should remember though. Sorry about that. You should remember arc length from geometry, or maybe you shouldn't remember, but you did learn it. So for arc length, for our intensive purposes, is S is arc length. And you guys, if you want to read this whole thing, it tells you how we came up with arc length. It equals my radius times theta, and the really important part on this is that theta needs to be in radians. So this needs to be in radians. Right. So make sure you pause, take some notes on this. There's not a problem to do on this. Okay. All right. Here we go. Now we're going to use it to try to do a problem. So use the circle at the right. What is the length of D to the nearest tenth? So D is our arc length. So D is S in this case. And remember, our arc length is radius times theta in radians. And they very nicely laid it out all for us here. So we can say that S is my radius of 3 inches. And then we want to multiply it by 3 pi over 2. So originally you get 9 pi over 2. Now because it's a length, this is when I don't want you to have the pi in there. I don't know if you guys noticed. Let's see if I can The lighting's not great. But see above the little caret, there's a pi symbol there. I really would prefer if you use that when solving these, like that's kind of the level of math we're at. We're not just going to use 3.14. So you're going to take 9, you're going to multiply it by pi, so you get there by hitting second caret. And then you're going to divide everything by 2. And so you can see it says to round to the nearest tenth, so I'm going to say it's about 14.1. And then because it is describing a length, notice that it says inches, so I'm going to put inches. All right. How would the arc length change if the radius of the circle doubled? I don't know if we've talked about it this year, but there's direct correlation and inverse correlation. And so if we doubled our radius and made it 6, at this point we would have 18 pi over 2. So you guys should realize that if I double my radius, I have my same angle, that the arc length would also double. So arc length would double. And you could check that, you could see that it would probably be around 28.2. So if we made this 6, we would have 18 times that pi divided by 2. Oops, I didn't mean to square that. So I'm going to hit no. Divided by 2. And we got it. We got that double. It would be about 28 point. And with the rounding, it ends up a little bit more than double, but 28.3 inches. All right, that's it. Good luck with your 2 tasks this week, and don't forget to do the exit ticket with review.